This new webinar. It's been quite a while since our last one. Today we wanted to introduce you our latest product, which is our porcelain 3D printing material. Before diving in, I just wanted to give you a bit of some feedback on why we developed that material. We've in the past, with our technical ceramics, we've received a lot of requirements for design applications, artistic applications, tableware, a lot of application that we were not really able to serve with our technical ceramics. And this is why we wanted to develop a material dedicated to this application, to design and artistics 3D printing. So I'll dive a bit into what is a porcelain material, how to print it, what's different with our other materials, all of these, and then some first use cases in this presentation. First, for those who don't know us, but I'm sure you know us by now, we will talk very quickly about who we are and how the Zetamix product line works, and then we'll go to the actual porcelain material. So just a short reminder that Nanoe, we're not a 3D printing company, we're actually a material company. We've got more than 15 years experience in producing high performance materials, mainly ceramics, also a bit of metal materials, but the core of our materials is ceramic raw materials for industrial production by traditional process as well as by 3D printing. So the company is 15 years ago and is 15 years old, and we started our 3D printing division 5 years ago. So that really does stress that these materials are just one part of our business. And when we started these filaments, we wanted to bring one thing to the market, which is to make a technology that allows to print ceramic and metal in a more simple and affordable way. We want to make these materials more mainstream. Currently, making ceramic and metal parts with other technologies than ours is usually quite complex and requires extremely expensive equipment. And what we wanted to change was this. Our mission is to make ceramic and metal materials easy to use and affordable. How do we do that? We do that by developing a line of filaments that allows to print these materials on standard FDM printers. That's really the big difference. It's now starting to be a relatively large list with technical ceramics like alumina, zirconia, and silicon carbide, with specialized materials, with steel material, with stainless and tool steel, and now with a new material, which is porcelain material. Of course, at Nanoe, we are a material manufacturer, but we also have decided very soon in our product launch to have the possibility to also offer the full complete line to use our material, and especially the post-processing equipment. That means debinding and sintering, and we'll dive a bit into those processes. Requires dedicated equipment, and we have partnered with different manufacturers to develop these equipments as well. So in general, how does that work? How does our Zetamix material work? It's fairly simple. The filament is actually a mix of some thermoplastic binders, plastics, to make it simple, different plastics in the material, and a powder with a very, very high volume loading of powder. We usually have more than 50 and 60% of the volume of the filament, which is powder, which means in mass usually more in the range of 80 to 90%. That's a very, very high amount, and this is what allows us to go through the process afterwards. Process being quite simply, we print the part using any standard printer. We then remove the binder by dipping the part in a solvent, and then fire the part, sinter it, put it in a high temperature furnace if you prefer, to get to a dense ceramic or metal. So with the technical ceramic, which is what we used to have, most of our technical ceramics will sinter under air, but with very high temperatures between 1450 and 1550 degrees Celsius. That's one of the limitations we wanted to break with our new material. We wanted to be lower in temperature, and maybe I'll explain a bit why later on. Now, if you want to do metal, it's exactly the same process, except that your sintering will need to be done under a neutral gas to avoid oxidation. That's the case with stainless steel and also with tool steel. It's exactly the same. Tool steel is not mentioned, but that would be exactly the same process. So now, if we talk about porcelain, you'll see that the process is slightly different, because usually most porcelains are going to be glazed, and I'll go back to what glazing is later on, so that adds some step in the process. It starts in the same way. We print the filament using any FDM printer. Then we dip the part in acetone to remove some of the binder. We do the chemical debinding, and then we fire the part. We go in a furnace, and in that furnace we will sinter the part at 1000 degrees Celsius. This first sintering will give us what we call the part-fired part, or a biscuit, sometimes it's called, which is a porous ceramic. And with that porosity, we will go through a glazing. Again, I will detail that later on before doing the final sintering. So we add a few steps in the obtainment of the final part, but you will see that these few steps are really critical to get fine, nice looking porcelain. So if we go step by step, there's a lot of text here. I won't go into details. The first part is printing. Printing is really the same as what you do with a we actually use standard FDM printers. There's a few specificities. The filaments are quite brittle, so we usually try to use printers that are have a good compatibility with this. They print at relatively low temperature, which means we have to adapt a bit. And of course, and I'll go back to that later on, but you have a shrinkage of the part during sintering, so you need to compensate it on the part you're printing. You're going to print a part bigger than what you actually want to have at the end. Then we go through debinding. So we have a part, here it's symbolized with that circle, which is just printed, so you still have the powder and the different binders in it. And now you need to get from this to a final part, which is in ceramic or in metal. How do you do that? The first step is to dip the part in a solvent, which will remove approximately half of the binder. At the end of that process, you should have almost removed all the soluble binder, but you still have what we call a backbone or a secondary binder, which is still there. And then you will take that part and put it in a furnace, and in the furnace, you are going to burn away the rest of the binder before sintering and to get a dense ceramic or metal. The chemical debinding is done, it's very simple with any vessel where you can put acetone. We use ultrasonic cleaners, but you could use something different. And we put the part in small baskets so that you can dip them in acetone and check that you actually have some loss of weight during this debinding step. Very straightforward. It takes a few hours to sometimes. We sometimes leave the part overnight if they are really big, but that's again a very straightforward process. Once you've made this chemical debinding, you put your part in the furnace, and what happens is that you burn away the part. To make that, you really need to go relatively slowly during the heating ramp. So we say between 7 and 10 degrees Celsius per hour. Depending on the part, it could be quicker, but we usually advise to be really slow in that stage, which makes the debinding process the actual longer step, the thermal debinding, the longer step in all of the process. And then we directly do thermal debinding and sintering in the same furnace, which saves some time and cost. So here we have a step that we will add specifically for porcelain, which is glazing. So we use glazes that we have co-developed with our partner Serinov that are compatible with our porcelain material, but you could probably use also other glazes from the market. This is really something very well known. We so have these parts which are white, which have been part fired and are still porous, and we're going to apply a liquid glaze to the parts. So you can dip them, you can spray them. Here we just coat them directly with the material, but you could paint them with a brush, whatever. You just need to deposit a liquid glaze on your part so that you have this nice homogeneous coating. And this is really a very specific process because in your liquid glaze, what you have are particles of, let's say, glass-like material that you just deposit, and that's absorbed by the porosity of your part. And then you'll put that part back in the furnace a second time, heat it very quickly, to 12,000 degrees Celsius. This second sintering is much more quicker than the first one. And in that stage, the particles of glazing will actually melt and fuse with the surface of your part. So sintering is a process that our customers already know very well, of course. It always implies densification of the part, and that means a shrinkage, always in the same range, something like 15 to 20%. The specificity with porcelain is this two-stage sintering, a first firing to get a porous structure, then glazing, then the second sintering. And the second specificity for porcelain is that the temperature is much, much lower, and we'll see that this is really important. So that's what happens during sintering. You have a densification and coarsening of the grains, and that's it. So we're launching this new line of filament, porcelain. So this is a standard filament, 1.75 spools of 500 grams. We are also launching with our partner Serinov all the necessary equipment and consumable. That means a furnace which is dedicated to porcelain and a line of glazes which are compatible, of course, with our porcelain. The porcelain filament itself, what can I say? It's for a ceramic material, it's relatively flexible. So it's quite easy to print. It's suitable with most printers. We've tested quite a few ones, and so for the moment we haven't had any specific problem. And compared to other materials, porcelain is a much more simple material, so it is more affordable. And just skip this. It's quite technical information. So you have just that one is important. You have 55% of porcelain in volume in the filament, and again, that's a very, very high amount. For the glazes, we've developed a line of ready-to-use glaze for our filament with 8 different colors, which comes into bottles that you can directly use. That's really what we wanted, something which is very simple to use. You can paint it, spray it. If you have enough material, dip your part directly in it. And it is a completely ready-to-use product. You don't have to dilute it. You don't have to do anything. That's what we like with this material. some of the interesting things is, of course, it brings colors, and we can have really very nice colors, some red, yellow, green, blue, and so on. It also allows to smooth the surface of your part very easily, and that's some important aspect of it. Mm. Yes, so that's something I wanted to stress about this, which is that compared to any other coating process that you may have with different 3D printing material, this is very unique because glaze is more than just a coating. You actually have really almost a fusion between the surface of your part and the glaze, which means you have an extremely strong binding between the two material, between the glaze and the part. It's usually almost impossible to scratch or chip out some of the glaze from the part. That usually never happens. If you try to do that, you're actually going to break the part. The glazes are scratch resistant. They're very smooth, which is really an interesting part. If you take an example, this is a part really printed in our porcelain material. I'm not sure we see very well, but you can probably see, maybe I should do that with the black, it's more visible. You can probably see that the surface smoothness is excellent without having done any polishing on the part. These were printed with very thick layers of 0.3, and the glazing allows to smooth out all of the defects you may have on the surface. Of course, it brings colors, already say that, and it's watertight and food compatible, which opens application in tableware and maybe other application in the food industry. So the second thing we're launching with this filament is a furnace, and we're really very happy to be able to offer this furnace. Again, with our partner, which is Serinov. This furnace is made in Europe. It's made by this partner, and that's one of the other interests of porcelain. The furnaces that you need to sinter porcelain at 1250 degrees Celsius are much more simple than a furnace for high temperature ceramics, which allows us to have a bigger furnace at a lower cost. And of course, that's very convenient. So that's a really very simple to install furnace. It comes with some in option a small table to put it on. It uses quite a low amount of power, so it's a standard 220 volt plug, which really makes it plug and play. I told you at the beginning what we want is to make ceramic and metal printing easy and affordable, and this is really going in that direction. These kind of furnaces are very simple, and I must also add that this filament is compatible with most ceramic furnace you can find on the market. That means if you already own a furnace, or if you have access to a furnace in any porcelain workshop or whatever, you can already use these. If you don't, then we have this great furnace to offer. And the last thing is it's a much bigger chamber volume than what we used to have for technical ceramics. So that allows us to think about bigger parts. And if we talk about design, artistics, and tableware, we're probably going to go to bigger parts. So now we'll go into a few example of parts and why our customers chose to 3D print them rather than do something different. So this is a first example, which is a very small vase made by a porcelain artist, which is called Vesna Garrick, based in Paris. So that's an interesting case because our customers wanted to print that design in different sizes. We started with a small one, but we're at the moment printing the bigger one. She did have a shape, but she didn't have the 3D file, so she actually gave us um, a plaster model, and we had to 3D scan it. And so we had a complete, from that start, we scanned the model, we had a 3D file that we had to work a bit on, and then we could directly start printing in different sizes to check whether or not this was a possible design. Interest of 3D printing here are quite obvious. It's a small scale production with very, very thin walls, which would be difficult by traditional methods. And it allows to do different sizes without having to do for each size a different mold. It's become one of our testing part for colors. So you can see here that we glazed it with our 8 different colors. The dark blue, black, white, orange, red, brown, yellow, and green. We have been experimenting with a few customers on coffee cups. This one is one of our design, but our customers have different designs. Unfortunately, we can't show them. But it was just to stress that um, this material is food compatible. It's also smoothed by the glaze, which makes it very easy to wash. So if you want to put it in a washing machine, that's not a problem. Of course, it's watertight, so you can have coffee in it. And the last thing is 3D printing here will bring a freedom of design. This part may seem pretty simple, but it's actually a double shell part, which allows to have your very hot coffee cup in your hand without burning your hand. Fairly simple application, but we can see some interest here from customers in tableware. This other part was done by actually a porcelain renowned industrial production manufacturer, which is doing porcelain by traditional methods, casting, slip casting, or some other pressing methods. The interest for porcelain coquet for this application was to say that for small series production, and especially for small series production of complex parts that are difficult to manufacture, 3D printing could really answer a specific need for them. So they're working with most renowned chefs in France, and sometimes they need to do volume production because for some restaurants you need a lot of tableware, but some smaller restaurants will ask just a few pieces. Maybe this will go for one specific meal, so they may need 5, 10, maximum 20 of these. And making them by traditional process for porcelain coquet is just not possible. And so the combination of the fact that this is a quite complex part to make and the small volume really makes it the perfect application for 3D printing. So we're still experimenting with the customer to try and go for bigger and bigger parts with the same design. It's still a process ongoing. Some example which are more design related. Well, all of these are for design, but we work with porcelain manufacturers. We also work with designers which are not expert of the material, and here 3D printing just give them the possibility to work with porcelain in a much easier way. You have a few examples here. This one is from a design company called Ball Design. The other ones are not. It's from the different designs. But just to give you ideas of the kind of stuff that could be made with porcelain. We have some example of personalization also. So these are really first examples, but the interest of 3D printing is that you can also personalize the part you're making, adding a name, a date, whatever you want on the part, even some small details. Some examples from an Italian customer who's making coat hangers in porcelain. And well, of course, 3D printing allows them to play with different designs and to experiment. And that's it. You've seen a few examples of this part, and on the right you can see parts coming out of the furnace, literally. So we just open the the furnace and took a picture, and that's a very satisfying sight when you have that kind of part coming out of the furnace. So that's it for this presentation. If you're curious to know more about this, the next place where you can meet us in person are Formnest in Frankfurt, of course, which is the main trade show for 3D printing. We will be there and we will exhibit well all of our portfolio, but we will definitely showcase this porcelain material. We're also organizing in December a workshop where you can experiment yourself, and technical conference day, which is actually organized by the French Ceramic Researcher Association, GFC, but it's co-organized by Nanoe, and we will be hosted in our office in Palaiseau. Of course, if you're interested in participating in one or the other, or both of them, you can contact us. Thank you very much for your attention. And of course, if you have any questions, I'd be happy to answer these. If you have any question, you can shoot them in the Q&A section or the discussion, whatever, and I'll try to answer them to the best of my ability. Apparently, no questions. That means I've been extremely clear and straightforward. They're coming. Anyway, I'm going to answer these, but in general, one of the messages I wanted to say is that we're still starting this product. If you have designs in mind and you'd like to experiment, you should really contact us. So a few questions here. So since we have questions from in French, I'm still going to answer them in English because we have a few English-speaking people. But so how thin can we print with this technique? So it's FDM. So we print like standard FDM. Typically, we've printed layers of 0.1 to 0.3, and the wall thickness, the smallest we've done so far is 0.4 millimeter. So that's really very, very thin. Of course, if I was to print that vase in 0.4 millimeter, I'm not 100% sure that it would survive the sintering process. So this one was printed with, I think it's a 1 millimeter layer thickness, but let's say it depends on your design. The higher it's going to be, the more you're going to need to have relatively thick walls so that it survives the sintering process and to avoid any deformation. So that's an interesting question. There's a question about the coffee cup and how do you sinter it, and how do you avoid how do you get the air out of the double shell during sintering? So actually, it is quite a surprising thing, but you can completely remove the air just through the porosity. So it's at the beginning your part is porous, and so the air will flow out. And when it starts densifying, it will become watertight, gas tight. That means you may have actually a bit of low pressure inside your double shell. You'll have less air than what you would have. It's not at standard pressure. So the cost of the spool. So all of our costs are transparent, of course. It's on our website, zetamix.com or zetamix.fr. A spool of porcelain of 500 grams is 99 euro. So that's pretty straightforward. So do we have any cracks in our sample after solvent debinding? So it can happen. Not a lot with porcelain because the kind of parts we've been printing are quite favorable for the technology. But it can happen to have delamination and cracks during solvent debinding. Usually that happens if your part is too thick. And so the solvent has difficulty reaching out to the core of the part to debind, to remove the binder, and that can cause problem. There's a few ways to solve that problem. One of them is that you need to be completely sure you've fully debinded your part before removing it from the solvent. So sometimes just prolonging the debinding time can help. You can play a bit with the temperature of the solvent, and you can also play on the thickness. That's if you really don't manage to solve your problem with debinding time and temperature. If you always have delamination, that probably means your part is too thick, and you'll have to make something less thick, possibly with some infill, or find a solution to adapt a bit your design. Is it possible to soften and polish a surface before glazing to glaze only some areas? Of course, it's possible. For me, the most simple would probably be to polish after the first firing, because you'll have something that will really behave very nicely on that perspective, and you can polish it very well. You could also polish it before the binding. Both of them works. It's just that, well, if you're happy with the glaze look, glazing will do the work for you, so you don't have to manually polish anything. Glazing will smooth it out. But of course, if you want to glaze only specific area and you want to have unglazed surface, that's a possibility. So how much does the printer cost? Well, depends which printer. These filaments are compatible with most printers, so you have printers ranging from honestly a few €100, and the one we showcase in our presentation, which is a printer from Ray 3D, which we really find amazing. This one costs €5,000, so that's the range. Depending if you want something professional that might be used a bit for production, or if you really just need a small desktop one, I'd say between €1,000 and €5,000. Well, I guess there's no more questions. You should really feel free to contact us if you have any other questions. And if you have ideas of application that you'd like to experiment with also, we are very open to, with new materials, we're always willing to play a bit and we try to see what's possible or not. So if you have any idea of application, you should uh, reach out to us and we can discuss this. Well, thanks again for attending this webinar, and I hope to see you at our next events, either online or on physical events. Thank you very much.